Hello, ladies and gentlemen. Welcome to our webinar for our brand new CarTrain, which you see behind us. It's amazing that we have you all here. So we have a lot of interest for this webinar. So this is why we just give you some time to join, get a last coffee.
If you don't know about Lucas-Nuelle, then yeah, welcome. Thanks that you're there to join us today. So Lucas-Nuelle has been a company around for over 40 years.
Yeah, definitely.
Close to 50 years. There is actually a Mr. Lucas-Nuelle.
There is a Mr. Lucas, and that's the last name. So it's Lucas-Nuelle, both is the last name. We had some mixed up back in the day. So it's Mr. Rolf Lucas-Nuelle, basically.
Yeah. Nothing to do with Lucas Electric, which you find from the UK back in the day.
Yeah.
Thank God, nothing to do with them. But yeah, so Lucas-Nuelle has been around for a long time. Obviously, we're talking about electric vehicles here with our CarTrain, but it's not. The company just doesn't do electric vehicles. We also have renewable energies and electric drives, automation, industry 4.0, building management systems, all sorts of things like that. And we focus on didactical solutions. So training people at universities, at trade schools, manufacturers, all lots of different types of areas, but learning about technology, I think we could say.
In a very modern and engaging way, I would say. And this leads us over. So we are based basically in Germany, West Germany, very close to Cologne. Maybe the name Michael Schumacher rings a bell at someone.
Yeah.
So his go-kart track is close by here.
That's true.
So back in the day, we went with a lot of customers there to have a good time. So yeah, that's who the company is. And yeah, basically Daniel and myself, we started more or less at the same time.
True.
15 years ago now, 15 years. Daniel had a longer way. So basically from my home to Lucas-Nuelle, it wasn't that long. From Daniel's home, it was pretty long. From Australia, basically. So yeah, maybe you just want to start with a few words about your career at Lucas-Nuelle.
Sure. So yeah, Daniel Brown, as Chris mentioned, so 15 years in the company. Yeah, 15 years, we get to do a lot of different things. So training around the world, setting up projects in different countries all around the world, but most importantly, designing and building equipment like this that's being used also around the world. So it's really, I guess, part of what we do is trying to design equipment. And in this case, what you'll see a little bit later is around, in this case, a qualification for electric vehicles. So making sure that we can try and cover qualifications using the equipment.
But I also want to add that you are an amazing networker. I think that was also really important for the success of that system right now, that you also integrate all the different curriculums all over the world. We later gonna do a more deep dive on that, but also being connected with all the car manufacturers, that at least you get so much input that you were able, you and your team, of course, he did that on his own. Yeah, that this great piece of equipment came out, basically, right?
Yeah, absolutely. So we work together with as many stakeholders as possible to try and, yeah, build the best equipment that delivers the most competencies to our customers in the end.
Absolutely.
So, yeah, yourself?
Yeah. So my heart also beats for automotive. Originally, I also was in the automotive team, worked together with Daniel for like 12 years. In the last 3 years, I got the chance to take over an amazing team here at Lucas-Nuelle, which we call the Digital Experience Learning Team. And we take care of all the pioneer stuff in direction of videos, AI, 3D models, webinars, so everything where we can engage and get in touch with the customers or give a higher benefit to our customers on different new channels, basically. This is what my team is doing and is taking care. And yeah, it's also one part of my team in the background. So thanks to Leon and Caro, maybe we will hear their voice later. They also are doing the, how you say, the background stuff. We are here in our official recording room. Very nice and yeah, decent room. So we're pretty happy here to be with you right now. And Yeah, then we start with our webinar.
Yep. So we've still got people coming in, but I think because we're going to record this session,
exactly,
this will get sent out as links to everyone. So we're actually recording 2 webinars. And because the way that Christian and I do webinars, we don't script these webinars or anything like that. We're able to just go through. It's quite possible that both webinars will be different. So we're going to send the links to both of them. And there might be something to learn or to see different from the 2 webinars.
The next one will be Thursday in the morning for German time. So, but there's also the official registration link. On the other hand, if you have questions, here is a Q&A section, and my colleagues will take care of your questions. Please just use this section, Q&A. You'll find it there in the team section where you can put in all the questions. These questions will be collected and we will answer them in the end. So just feel free to ask nearly everything what you want, and then we're going to give you an answer for that. Okay, you're all here as you facing the challenge, or you're interested in delivering a new level of EV training. I mean, we don't need to go in detail here. EV is obviously the future for our motion, for our automotive, our automotive future for the world. Doesn't matter where we are. Maybe in one country it's a little bit faster, and the other country it's a little bit slower. But definitely everything is heading into the direction of EV. But this, of course, brought a complete new set of challenges for the apprenticeship for automotive. So from the classical combustion engines, our instructors suddenly facing, or you as instructors are suddenly facing completely new challenges. And these new challenges also require new solutions, right? As maybe we can say a little bit to that as well. The standard car, or just buying a car from the car market for the training, is not necessarily the best idea, especially when we're talking about a high voltage system where we want to work in and diagnose. So repair and diagnose. And that's the headline for our CarTrain, right?
Absolutely. So, as you mentioned, there's basically new apprenticeships. So not every country uses an apprenticeship, there's a different name, but the training for a technician, which you find automotive technician today, there's some are integrating electric vehicles now as we speak. Some don't do that. Some add that on as an extra qualification on top. And so there's also further training for existing technicians. So we're not just limiting to the people that are coming through their training now, but there's obviously the people that are working on the vehicles are going to be seeing these vehicles as well. So there's a number of different options out there. So there's different qualifications. As we mentioned, there's an apprenticeship, which, you know, as you come out of school and you go into the workforce and start working, you might need to incorporate the electric vehicle there. But there's also these qualifications that go on top. So for example, here in Germany,
that's what I want to mention. And there we see that we have a whole bunch of curriculums or standards right now all around the world. There we see how serious it is with EV training, basically. And yeah, of course, as you mentioned, in Germany, we have DGUV, basically. Then we have in the US,
ASE L3.
Then, of course, from the UK, but which also counts for the whole world, is the IMI EV training qualification or standards. And we also have from Singapore the NESS. And also, what is interesting for Canada, it's the Red Seal-based training, or the Red Seal-based EV training there. Basically, everything fits to the specific needs of the country, but the core is always the same, right?
Well, as you've often mentioned in the past, Christian, so a vehicle, a Prius in Germany is the same as a Prius in Japan to a certain extent. Of course, there's little differences here or there, but so
the heart is the same.
Exactly. And the way these courses are, or the qualifications are built, might slightly vary according to the country. So as you mentioned, for example, the DGUV here in Germany is actually, it's in the US, you would call it OSHA, so the Occupational Health and Safety organization. And that is quite interesting because they're the ones that they set the training qualification here in Germany. That's not the case in other countries, but they still go through and focus on the safety aspect. So there's a theoretical side that you need to cover, so in order to understand what you're working on, but the focus is on safety.
Absolutely.
And that's what you find in a lot of various curriculums.
And hands-on competencies.
And hands-on competency. So, and that's, for example, with ASE L3, if you have a look at the task list that they say there, which you can download, search for ASE L3, and you'll see that. And there it'll tell you, you must be able to diagnose faults within the inverter, in the battery, insulation faults, and things like that. So it tells you exactly what sort of, in the end, skills or competencies you need to have.
And the great thing what you have done here in your team is like you got all these curriculums and standards together and make like a complete picture out of it, which you used as a base before you developed that CarTrain.
Absolutely. So we looked at each of those curriculums and said, okay, we need to do this type of fault, we need to do that type of job. And before we built the system, we made sure, okay, this needs to be a part of this system going into it.
So before we now come to the overview, what we see here, just what we don't see here is also interesting. In order that all the curriculums can be integrated in here and into RXLea, our brand new learning environment, basically, what you will see later. But there will also follow up own webinars for it. So we won't go in much detail for that. We will just show you some examples of it that you just get an idea how great it fits together. But on the other hand, you have also generated a generic, complete solution for EV training. That means no specific car manufacturers running in the background. So everyone can use that. Every car manufacturer can use this. Everyone else can use it because you're not down to any specific car. And this was realized because you have developed a own car which runs in the which is the brain of the system, which runs in the back.
Yeah, absolutely. So this is the vehicle that you see here. It's a generic vehicle. We actually designed this in 3D, and the whole vehicle infrastructure is there as well. So the battery, all of the different components that you see.
Energy flows.
Everything is built into there's actually, we've gone to the trouble of making a mathematical model of this vehicle, but not only as an electric vehicle, but also as a hybrid vehicle, and the different types of hybrid vehicle, a fuel cell vehicle, so that we can emulate what's going on within a real vehicle. Like
that's interesting. So compared to when you buy a certain car, you have here more or less all the existing drivetrains integrated, right?
Correct.
So that is the, you say the EV, at the different hybrid types like parallel, serial, and power split?
Series power, or power split. That's the classic Toyota type that you find there.
And even fuel cell, right?
And fuel cell as well.
So there you see one CarTrain fits it all.
Yep.
Basically, all the different cars which are on the street are integrated into that CarTrain. So that fits perfectly here, that you really one CarTrain and you can switch within seconds from the hybrid to the EV to the fuel cell.
So let's have a look at that. Leon, I think you're able to zoom in on the screen here a little bit. But for example, one of the big things that we experience with students is being able to see how systems react. So what is the energy flow within vehicles? So this was something that we got a huge amount of feedback from, saying, okay, great, I can understand this. Now, you can often see this within a vehicle when you drive an electric vehicle or hybrid vehicle, but if you've got a vehicle like that in your class, in your workshop or so, you're probably not going to let the students drive it around the street under the different sort of circumstances to understand this. So we've done this here, so in order for you to see what the difference is. Now, as we drive along, what's interesting right now is I'm driving the vehicle downhill, or I can put my foot on the brake. What I'm not seeing here, any regeneration. So regeneration normally occurs when you can see that on the energy flow here as green.
Yes.
But because my battery is at 100% state of charge, it's not going to regenerate.
Ah, okay.
So what I'm going to do here with just a simple flick of the switch, charge my battery quite easily. And we can see here the energy flow, the recuperation going down a hill and recharging that battery.
And that's on a multi-layer level. You just do not just see it here in the picture, you also see it here everywhere around the different components, right?
Exactly. So as I just accelerate the vehicle, you can see now how it changes. Doesn't come up the greatest on Teams, unfortunately, but it's changing between blue and green.
But that's pretty amazing because, like you said, here it is just virtual, basically, like you would see it in a car.
Yeah.
But here you can directly connect it with the real high voltage system, which obviously is not possible on a real car, as I haven't seen that every car manufacturer put LED stripes into his high voltage system.
Exactly. And, you know, as you said before, look, vehicles are not necessarily the greatest way to teach people how to understand these types of vehicles. I mean, when I did my apprenticeship back in the 90s, early 90s, it was all about, you know, we had distributors and carbies and obviously combustion engines, but you had camshafts, you had crankshafts. You can literally follow the mechanical components of that motor engine and say, okay, I can understand the logic of how this mechanical motor works.
And there were centuries of experience, basically, right?
Exactly. When it comes to electric vehicles, a lot of people still talk about it as a big black box. So especially when we get to the inverter and three-phase motors and things like that, it gets a little bit difficult. So what we try to do here is to put the whole drive system of an electric vehicle on the front of the CarTrain here and to make it as sort of understandable as possible.
And now you're in recuperation mode, right?
Exactly. Recuperation right here. And the thing is, I'm with a battery electric vehicle, so it's probably not the most interesting right now. So we can go up here. We've got vehicle settings.
Okay.
And as you said before,
so there is just that parallel, serial, hybrid, power split hybrid, and fuel cell vehicle.
Fuel cell. I'd say the most complex is the power split, or the Toyota
Prius,
type,
for example.
So let's just switch around to that. The system has now reacted, and we can see all of the components that are a part of that.
Oh, yeah.
So we're still driving along now, and we can see here, so during either acceleration, so I'm trying to accelerate here, or say, for example, going uphill. But I can also completely discharge my battery, or not completely discharge it, but I can make it very low so that we can see here, and I can even come to a stop, brake the vehicle as I'm braking. We're also recuperating the energy there.
There's really resistance like breaking down, so you're not just at other standard training system where just at zero then.
Stop.
You really, that's again this vehicle model in the background.
The mathematical model in the background is, and we can even measure perhaps we'll connect up the current clamp in a minute, but you can see here we've stopped and the motor generator 1 is currently operating and charging the battery in the background while we're sitting there.
Cool.
So, and that then, like I said, we can do that for fuel cell, all that sort of thing. We only have 1 hour here today, so we've had a deep dive on this. I dare say we're going to make some more videos.
So like I said, these videos will be shared with you. So if you want to dive deep, you can do it with our deep dive.
Exactly.
I just saw it before when you went to the options mode. We say now km/h, but just by flicking a switch or the touchscreen, you can switch that to miles per hour.
Miles per hour is there as well, so quite easily.
You've designed the system so that this one fits it all again. Basically, you can use the system everywhere in the world. Doesn't matter where you are.
Absolutely. So we've got customers all around the world with the system. So
and we traveled all around the world.
And we travel.
Know a lot of you guys.
Exactly. So we try to design that in from the start. Another thing that we're probably looking at doing next year is having a truck on here as well. So we had a lot of people saying, hey, look, what you've done here, which perhaps we should have a quick look at what the construction of the system is essentially the high voltage drivetrain of a vehicle. Doesn't really matter if it's a car, a truck might be very similar. And so next year we'll have here a truck train version of this as well.
Okay, then let's have a look what we see actually here. I mean, I can start above here. This is what I'm familiar with still. So what we see here is basically the different methods for the first responder shutting down of the high voltage system. So it's not the official way how you would do it in the directly in the workshop. For example, the cutting loop. So, okay, I think it's a no-brainer. You won't cut the cable every time when you need to do a service or whatsoever on the high voltage system. But of course, it is there, as also this goes into the concept of having a complete solution here. So not just one way of shutting down method, but any way of shutting down method which exists is integrated into the CarTrain. So like I said, the cutting loop. Then we have the low voltage service disconnect. So I'm allowed to touch this without gloves. Speaking about gloves is also interesting. The whole PPE section is also part of the CarTrain, right?
Absolutely. So that's an important part of each of those curriculums or qualifications that you have, is understanding the curriculum. And so that's an integral part of when you shut down these systems using the gloves to do so.
So and that will also be later in the diagnostic task with RXLea. PPE is a crucial part of it. So yeah, you can buy it from us. You can use your own gloves basically. Yep. But the system makes sure, or the whole e-learning makes sure, that the PPE is used basically and explained.
Absolutely.
So, okay, so this is, even when the system is completely student safe, of course, PPE is important from a trainings aspect.
It's absolutely critical.
Then let's go on here. Then we have here the so-called high voltage fuse, which is of course not a high voltage fuse, but in a normal 12-volt system. But when you pull it out, it basically shuts down the control relays, and which disconnect the high voltage battery from the rest of the system. Then pretty cool, a smart key we have here as well. And I think it works like a real smart key. It's not just a nice thing there. There is smartness in it, right?
Absolutely. And cool. That's a part of the shutdown procedure that we'll have a look at shortly as well.
And the last thing where I'm familiar with, this is of course our onboard charger. That means it's not the most important part of the system, but also of course it belongs to it, the charging connection. And here you see now the type 2, and just we say it's a generic one. If you want to have the CarTrain in a country where type 1 is used, that's no problem. So there's also a version where this guy is replaced with a type 1 charger.
And if you're not sure about the difference between type 2, type 1 is type 3. Type 2 has 3 phases. So here in Europe, for example, you have it's a lot more common to have 3 phase at home. So you have here also the chance of 3 phases. It's not always the case that you have the 3 phases. And in where you use the type 1, so type 1 is used in the US, Japan, Australia.
It's the one with the mechanical lock, right?
Exactly. It's got a mechanical lock, and that's only single phase, so it only has the 2 power cable. Throw the charger in. We've got the charger right next there, and let's just see how it works. So this is a charger that we have, but any old charger should basically...
Oh, sorry. Safety first.
So put that in there, and
cool.
And the system, maybe you heard that, goes through the check procedure to make sure, and then charges through.
What else is the button here? Is that a button?
So the charging button there, so you mentioned type 1 has a button on the top here. This one doesn't have a button.
Yeah.
So it's try and pull it out.
Yeah,
it's actually
locked.
It's locked, because you don't want to just pull that out, because there's a lot of current going through that charging right now. So you have to stop the charging process.
It's interrupted.
Exactly. And of course we've got an LED there. So it's telling you green, everything's charging, everything's good.
So like you said, this guy over here is like an optional device if you don't have any charging station at your school or training center. But of course, if you have a wall box or whatsoever, you can use this.
You can use it. I will just say that we've had, that goes on the CarTrain, the other one. We have had some experience with wall chargers. Just because a wall charger is a wall charger doesn't mean that it fits on everything, because there's a pretty fine line with the communication, which we can also read here as well. So, but that's the point. It works, and that's part of the training as well.
We see that later on the other as well. What is super cool, and this is why it makes such valuable training system, or one reason for it. It's not just the original part over here where you have all the connections like PP over here, PE here, and CP there. You also brought it out basically for safety reasons that you have it here in the real component, but also here for the students that they can easily connect with any safety measuring leads. Here are the safety 4mm measuring connections where you can directly measure into the charging process while it's plugged in and it's charging. You can see basically how the wall box is communicating with the onboard charger, right?
Absolutely. And the different types of, so wall box or even the type of cable that you use affect the communication that you have.
Which is PP, yeah.
And of course we have faults within that system that has its own project that is in Leah, but that's something we'll go into a little bit later. So
okay, let's go to the fancy parts here. Now I need your help.
Yeah. So you see here we've got actual real components here. These are actual connectors from industry. So
from the automotive industry.
From the automotive industry.
Yeah.
We've got down, so yeah, exactly. We'll start down in this bottom corner of the system. So you can see we've got these gray boxes around everything. So what we've done is split the whole system up into the different areas of a high voltage vehicle. And this here, for example, is our high voltage battery. So we've got our manual service disconnect at the bottom.
Strong guy.
And you can see down each side is the two parts of the battery. Now, each manufacturer does something slightly different. They split the battery into 2/3 and 1/3, exactly. But for sake of clarity, we've just done it here that the battery gets split in half.
Why not? And then again, also the measuring points, and we would measure here when everything is okay, real 400 volts, right?
Yeah, absolutely.
So it's a real 400 volt high voltage system, basically.
So we can see that. Do you want to just plug it in? So right now, obviously everything is safe here, and we're just showing the systems. Well, that's one side. So here we can measure 1/2 of the battery. Now, I said
because we're so low, right?
Exactly. So the state of charge is quite low. I don't know, Leon, are you able to just zoom down on this bottom? Yeah, exactly like that. Maybe Chris, you can. Well, so right now we're seeing 160 volts or 162 volts. As I increase the state of charge,
let's do some magic.
So state of charge is effectively the voltage of a battery.
And now we see it. We have here the 200.
200. And this is...
Yeah, same on the other side.
This is really what you find in vehicles as well, is the dynamic voltage of these batteries. Like they're not... I always find it funny that a lot of technical books say the battery is 203.6 volts, you know, in the Toyota Prius Generation 3 or whatever. That's the nominal voltage.
Normal, yeah.
But it changes. It varies quite a lot. So, for example, if I bring that state of charge down now to almost empty, so it's going to change. This is a part of that mathematical model that I mentioned in the background. So,
that's so super cool. It's like having a real car, but don't having the stress with a real car.
Yeah.
It's so easy to understand now because it's so visible and you don't need to dismount anything. You just go to the measuring points, and even for a student who just starts with the topic, it's super clear. One side, and both together we have the 400 volt. But when we drop down with the state of charge, we directly see a real value. Nothing is simulated. So what we measure here, this is a normal guy basically from the industry, the Matra hit one, which measure the real voltage here.
Absolutely. So of course, the big difference is that we have huge resistances in the background here. So there's protective resistances, impedance resistance there, so that there's no current is available at these points here.
So that means when we have a really smart guy or really, how you say, Crocodile Dundee type guy, even when he do something really stupid, nothing will happen to him.
Exactly. Or the system itself.
That's very good for our instructor.
So now, obviously, we don't see system like measurement plugs like this on real vehicles. Even though on the Toyota, we did find that the measurement point there is you can measure the voltage there, but you don't normally have that. So this allows you to have a look a little bit closer and see what the signals of the systems are in detail. So, for example, if you just do one last measurement here while we're there, and just go on this side of the relays, please. So I just mentioned we have our
we're not in ready mode.
High voltage battery here. So I was just coming to this section here, which is our high voltage relays. Now, they have a few different names. So some people call them contactors, some people call them system main relays. That's the typical Toyota name, for example, or yeah, high voltage relays. In the end, what they are is switching the battery onto the rest of the system here. So this here, for example, is our DC link. So this is putting the battery is obviously a DC battery.
Because we have two cables?
Because we have two cables. You can see just over here we have three cables, but we'll get to that in a minute. But just to keep on this section right here, so you can see here we have relays, and we'll have a look very shortly about what those mean, because there's different types of relays which we can swap out here
I
as
was
well.
going to say, it looks like you can take it out.
You can take that out, in fact.
I
And
couldn't believe it, because that's like...
And so what you see right now is we have 0 volts, basically. We've got 1.5 millivolts, if you can't quite read that on the screen.
Yeah.
Essentially 0 volts. So that's because we're not in ready mode. So what happens now is if I start the system up, you can see here, all of a sudden, we've now got a voltage, 410 volts, 12 volts, and that's the voltage now available to the rest of the vehicle.
And there was now multiple clicks, so basically the relays just done their procedure.
Yep.
In order, then they just activated or connected then the high voltage battery with the high voltage
Exactly.
system.
Basically, we would need another hour webinar just to go through that there and show you. So we'll think about if we can do that or not. But you can see that that now has the 400 volts at the system there. And yeah, the system is then operational.
I have also heard another name, maybe you can help us here as well, where they always talk about smart relays. Is that also part of this?
It is. So we can have smart relays. So smart relays are the relays that do a weld check each time they start up.
That's why they're smart.
Exactly.
Okay.
So there's conventional and smart relays. So we can go into that. Like I said, that is a whole webinar for itself.
Sure. But just to make that sure, so you have here the chance to choose conventional relays where you don't do the welded shut check, and then you can also activate the smart relay function, which is more or less an added feature, software feature, and then these relays gonna check them if they are fine before they go live, right?
Exactly.
Okay, cool.
Exactly.
And you mentioned as well, of course, the current is low, but what I see here, you have even integrated a current clamp, right?
Exactly. So perhaps what you can do there is just connect up the current clamp to that there. So obviously as we're driving, we can then see.
And it's that 1 volt is 100 ampere.
Exactly. So right now we're looking at 3.7 volts, 3.8, even 4. That's the acceleration that we had here. Oh, now my battery's gone flat.
I just was scared while the time was running down.
So,
okay, cool. So there you see as well. So your car doesn't stop at a certain point. It's a whole car. So really, when you're going flat, the car will shut down then.
Exactly.
Cool.
We've even put in the road resistance and the air resistance into the model so that it can, yeah. Anyway, so all of that is there calculated. Then we have the next section here, which is the inverter. So the inverter is then what converts the the DC signal into an AC 3-phase signal for the motor.
Okay.
But the inverter is also like a general term. Some people call it power electronics. Many different names. It doesn't really matter. We can see everything that it's doing here. So, for example, we also have the power supply going to our onboard heating, which can be for the battery or for the cabin. Mm-hmm. We also have the compressor, which is the same. Sometimes for you both, have for the battery to be cooled as well.
Yeah.
And we have
remember Dubai driving with EV cars.
Yeah, exactly. Even when you're charging with some of the the high capacity chargers that you have now, the battery gets really hot. And then down the bottom here, we even have the DC to DC converter, which maybe you can explain what that does.
The DC-DC, yeah, of course. So basically what we have here our 12-volt battery. You see it here as well, which is also connected with plus and minus with our quick release things. And here we have then basically a DC-DC conversion from the 12-volt battery towards the high voltage system and towards the high voltage distribution.
Exactly. So Nice one. Nice work. So exactly, in a normal vehicle, you would have a alternator within the vehicle to charge that 12-volt battery. On an electric vehicle, you don't have a combustion engine to drive the alternator, so you need to do that another way.
No mechanical parts, basically.
Exactly. So you have the DC to DC converter, which is inside the inverter, and that charges the 12-volt battery. And the way we can show that it charges, so hopefully, again, you can see that. That's 12.4 volts on the voltmeter. We're measuring directly on the 12-volt battery down here. And as I start it up, you can see how it bumps up to...
Like you would have an alternator, basically.
Exactly. Exactly the same.
Does it also go in the other direction somehow?
So that gets a little bit more technical. That's when we come back to our system main relays. There's a modern type of system main relay, which doesn't have a pre-charge relay, and we use the DC-DC converter to pre-charge the inverter.
Okay, we see this later.
You see that on the deep dive. We'll have a very quick look at it later.
Cool. And what's pretty cool here, what I see, it looks also that this high voltage distribution with the fuses, you can also open, right?
Exactly. So we've got the, this is the inspection point that you have, and the inspection point is what we need to do for live dead live testing. So we'll have a look at a live dead live test shortly, and go into more detail about that. But we also have the real fuses here for the various systems.
Okay, like I said, that we don't running short on time. I think it's super cool just to get in touch with the diagnostic projects, just to finish that here as well. I mean, that are, again, the things what I can explain. So pretty cool here. We see it in a minute while we have this. Here's a jump start. I won't say much to it now, but this is also important. And pretty cool for the lessons. We have our HDMI connection. That means this guy over here, so this touchscreen content, just by connecting this with the HDMI cable, you can transfer it or put it on a bigger screen or whatsoever, wherever you want to show it. And we have here our measuring interface. So that means, of course, on the CarTrain, you can use your own oscilloscope, you can use your own voltmeters. But on the other hand, everything is also integrated here with 4 channels, like a 4-channel oscilloscope, 4 voltmeters or whatsoever. And this then is used with RXLea together. So speaking about RXLea, maybe just a few words, what RXLea is?
Yeah, so RXLea is the learning environment where we're going to give the students the whole, how do they use the equipment. So we don't expect them just to come here and start understanding how everything works. They need some sort of environment where they can be guided through the process. So the entire theory that someone needs to know about the system that they're working on. When I say the system they're working on, here we're going to show you in a second about the projects that we have. So what that means is the students are going to be given a diagnostic case, and they get given then the information that they require in order to repair the system.
I think our friends here see now the RXLea screen, or they can see it. Okay, yeah, perfect. This is how it looks like, basically. We don't want to spend too much time here, but what I think it's important to say for RXLea on the one side, that this really goes a new way. It's not just a bunch of e-learning content. It's really a diagnostic and repair task guideline, which takes you at hand with different difficult levels. And there you see it's a little bit game-based, that you really can work through your, how you say, to your
goal of learning path,
basically. And with each step you take on your journey, let's call it this way, you gain experience, you gain competencies, you gain hands-on training, basically, right?
Exactly. So, and these learning paths that you see here might actually be different. If you're doing a DGUV, might be different than the ASE.
Everything's adaptable.
Exactly.
And everything is integrated. RXLea can be completely integrated in your existing LMS. So it doesn't have, if you have Moodle or what is that, Blackboard, exactly. Canvas, all those things are adaptable with RXLea, can be integrated into it.
Absolutely.
Okay, I would say, as the diagnostic part is the most important and the repair part is the most important part of this CarTrain, what you get later is here, this overview as well. You don't need to see it right now. I just want to show you that's really there. Here I see the number 28. So with the CarTrain in the end, there are 28 different diagnostic and repair projects which can be achieved with the CarTrain together, right?
Absolutely. So might be a good time to bring out our project case as well. So there's...
Oh, wow. So that's a crucial part of the system as well, scope of delivery, right?
Absolutely. So this comes included with the actual CarTrain. So it's not an optional extra or anything else like that. It's
nice.
Literally a part of the system. You get that every time. So what we can see here, you can see there's some of this looks familiar. So right here we have our cable that we have for the DC side. Put that there. We've got the 3-phase cable that we can see here. We haven't mentioned these yet. These are potential equalization cables.
Important.
Very important thing that we have there.
See a fuse?
A fuse. And this fuse is actually blown.
That's not the only blown thing, right? Or broken thing.
No, exactly. So all of these are broken. We don't want to give away all our secrets right now because some of you are students and you might actually be working on this system later and you're going to have to work it out yourself. But essentially what we have here, so we'll have a look shortly about what this is, and we can see here we also have a measurement adapters here as well, because we don't want students back probing these connections or measuring from inside of here. That's,
I think it's like
really
not official rule. You got shot if you do that, right?
Exactly, unofficial rule. And there's a spare smart key there.
What about these guys? Well, I just find pretty cool. I mean, these also exist on real cars, but they are hilariously expensive if you need to buy them.
If you buy that for one of the manufacturers, you're probably looking at thousands of dollars or euros. Or
part of it, easy to use.
Yeah, exactly.
Nice. So basically, we have then visible and non-visible faults.
Exactly. There's faults within the CarTrain, and there's real faults within these systems that you see here as well.
Like you have a real damaged cable, maybe from an animal. Or
we'll have a look at that in a minute.
Okay.
We'll do that one. We'll do this as exact project that we see there. But just to go through, finish up this one here, we now have a look at the other side of the case, and we can see here, so there's one missing that's installed on the system itself right now. Now, if you can have a look, each of these are slightly different. So hopefully you can see that on the screen. I'll lift this up to the, well, that's upside down.
Unfortunately, you're not sharp.
There you go. There you go. All good. All good. So you can see here, there's a slight difference between them, and that's the way this part in the middle, the resistor, so without the resistor. Now, we've just been given the sign that we're talking too much.
Yeah, exactly.
So we better get on so we can show the actual project.
But essentially, here again, this goes hand in hand with this generic idea. Also with this situation with the different relay versions here, it is possible to show or to simulate every real car, right? Because that are all the configurations which are existing on the market.
Absolutely. So there's 3 different types, because you can have a pre-charge resistor on the positive side, on the negative side, or no pre-charge resistor whatsoever, which is then pre-charge goes through the DC to DC converter. They are the only versions that are available and will be available. So we cover all of those bases there.
Okay, then let us have a look at a certain project. Oops. So your colleague told me that I should ask you for the 12-volt system discharged. What about this?
Okay.
So why he said I should ask you for this project?
So we actually looked into the statistics for the roadside assistance around the world. And the #1 fault that we found is a flat 12-volt battery. So have a look here.
Okay, now I see you can activate. So there are 2 ways in order to activate the fault. You can do it directly in the CarTrain if you don't want to work with RXLea in this moment, but you also can activate it through RXLea later.
Exactly.
Okay, cool.
Yep. So now if we have a look at the 12-volt battery, you just mentioned, so that was the biggest fault that we see on the vehicles is the flat 12-volt battery. We need this section up here. Sorry, Leon. Yeah, perfect. So flat 12-volt battery. That was the #1 fault recorded for electric vehicles. And so what that means is here, right now, the vehicle has 0 reaction whatsoever.
It's like when you turn the key and nothing happens.
Nothing at all.
Okay.
So in some cars, you hear the click, click, click. But this is a completely flat battery. Now, you mentioned before that we had the jump starter here.
Jump start down here, yeah.
Exactly. So there is a special procedure for
that would
jump
be like a booster package which you can buy and so on.
Exactly.
Okay.
So you got a booster pack. We've built that in here so you don't have to buy one. Now, the way you do that is we would connect the, don't need the multimeter yet, or now.
Okay. You just connect it with a 12-volt battery, right?
Connect it with the 12-volt battery. The other side, actually, you need to put that to ground. So put that there because there might be faults within, like what happens when a battery is completely discharged is that it
must be a
goes flat.
Yeah.
What I just forgot, of course, though, is the LEA project. So maybe, Leon, if you're able to just quickly go back to my screen. So I'm just going to show you what that looks like just briefly. So this is the scenario, what we call a scenario for working on the vehicle. So there's going to be, as you said before, projects, 28 different ones. This is just one of those.
Okay.
And we're calling that the scenario here. So you've been given here information. So the vehicle has been towed in. According to the customer, the vehicle can't be opened with the central locking with remote control, and it can't be switched on to ready mode. So you've got then the information, and then we go through. So I'm not going to go through all of this because we're going to run out of time. But essentially, with the there's lots of questions here to get the student to think about the case that they have there. So, and then preparing the diagnosis. Now, one of the first things you need to understand about, especially modern vehicles, is when the battery is flat, you can't open the vehicle because most keys, you have a smart key or something with the.
Yeah.
So when that's flat, you have to then say, oh, how can I go about that?
Okay, before you have hands-on with your hands, you have first hands-on with your brain, right?
Exactly. Now, of course, the animation's not loading, which.
Well, I think we
don't
have the best internet connection.
Yeah. So you have to go through here, for example, and there's how you open a vehicle.
That's what I mean. You really.
And so this is actually a part of the curriculum, especially in IMI. They specify how do you jumpstart a vehicle. And so you need to be able to open the vehicle with the key in order to do that. So, and I'm actually clicking on the various components here to get that.
No, it's not just seeing, you really have to interact with it.
Exactly. So I can click around here. Oh, battery's over there. So I need to go through.
Okay, I see. So, yeah. Okay, you have the battery there, and
so that's halfway through. And then go through with the questions. Where's the key?
Yeah, where is it?
So
then you can answer. So the student has to answer all these questions. Basically, that must be yeah. He cannot just jump over it, or he has really to go through the whole process.
Exactly. And so where we bridge that gap between the hardware here and the real vehicle, then we can cover on things like the animations here. So this is then giving the background on the high voltage system, the 12-volt system. How do we check that? Giving the animations on how to do that check.
Okay.
What to do there, which voltmeter, and all that sort of thing that you need there. So that's all included here. Again, I think we're going to show those.
Just one question. That means, but also the complete diagnostic tester would be part of RXLea then, right?
Exactly.
Oh, that looks super cool.
So this is the point that we're up to now.
Yeah.
So doing the jumper pack on the 12-volt system. And this is the vehicle that I was talking about in the background there. So that's the complete high voltage battery, the power electronics, the motor, gearboxes, everything.
Okay, this vehicle lives in the CarTrain, but also in RXLea completely.
Yep,
cool.
Absolutely. So that's what we're looking at there. We'll do a video just on LEA at some point. But now you can see here, we've done the jump start, gone through the diagnosis, and let's see what happens now.
Now, okay.
And now we have our system operational. We can drive away. And what we can even do then is remove our jump starter.
So that's all.
And stop the vehicle.
So that's all. So that's
shut down.
So that's all.
And then
so that's all.
That fault is now gone. We can start the vehicle up again because the battery was flat.
The battery was just flat, basically. There was no other part or other issue which was the problem. It was here really the 12-volt battery. Okay, I got it.
But if you have a look at the projects that we have there, we've actually got other faults where the fuse is blown, for example, is one. So the students would then have to go through, blow the and change the fuse. Or the DC to DC converter down here is also faulty.
Okay, and then we of course have to do, or the students have to do something else. The diagnostic way will be different.
Yeah, exactly.
Okay, cool. Then thanks for giving us the insight. I think that was one of the first insights into RXLea up to now. So thank you for that. That was amazing.
We're really excited about RXLea because that's it's basically state of the art for vocational education.
Yeah.
We have to say that, you know.
Really experienced learning.
Really experienced learning. That's what RXLea stands for. And, you know, it's really about giving not giving more information, it's giving that whole context of what someone needs in order to do that.
And this is aligned then also to the different curriculums, right?
Absolutely. That's more aligned to the...
So like what we see at the first, like this, how do you call it? The cherry tomatoes tree there?
Yeah.
This could be then, for the US, it would be based on ASE L3. For Europe, it would be, for example, based on DGUV and any other, or IMI or whatsoever, depending on what the customer wants.
Absolutely. That's what it's all about, and everything that they need there in order to go through that. So
okay, you sneaky guy. I've just saw it now. You replaced now the cable here.
So that's
okay.
I think what's also pretty cool to mention here, what these guys don't mention very often, but I just love it. A normal car could be really reduced to the to the amount of how often you can release a cable or release a component. As this is a training system, of course, you will never run into the situation that the car will be blocked and stopped and you can't use it anymore because you have too often disconnected cable. Here you can go on as many as you want to.
Absolutely. Yeah.
Cool. Okay.
You know, and if you lose something like this, if something gets broken or lost,
you can
we have all that. That's everything that can be ordered as well. Now, I'm going to give some forewarning. We're already at 5 minutes too.
Yeah.
So we're going to run over. If you have to go, these are being recorded. You'll get a link to this after. But if you're happy to stay around, hang on in. We're going to go for a little bit longer. And because I think we want to, we're really starting to get to the meat of the webinar right now. So now, as you mentioned, I just came along and I replaced something on here. So I'm going to try and start the vehicle again.
Okay.
And we can see there, I've got a fault warning that has come up, especially now as I've started driving the vehicle, because as we've driven it, we can see here there's a yellow fault that's come up here now. And I can go into my scan tool, which is in RXLea there. And if I go through, read the faults, I can see there that there's a insulation fault, which has come up.
Ah, cool.
So you can see that right here, insulation fault detected. Now, because this is about the learning, we don't, on a modern vehicle, it's most likely going to tell you exactly where the fault is. But we want the students to go through the journey of understanding what that is.
Of course, yeah.
So if I have a look here, okay, the customer comes in. Now, of course, this is a project scenario that we see. There's going to be, for example, for this case, there's 3 separate scenarios for insulation faults.
Nice.
So this one here is called a animal bite. So the customer might tell you that they have So I think the English word here in Germany is martens, but they might be mongoose or marder.
Yeah.
There might be rats. There could be
Whatsoever.
anything. It could be a stick that came up and hit the car. I've seen that in the workshop as well.
Drop bear in Australia.
Drop bear in Australia. They're horrible, those things. So now, in order to go through that, there's a procedure to go down to shut the vehicle down in order to be safe.
Of course. Okay.
Now, I could just go along and remove these cables.
Yeah.
Because I'm going to be safe. I'm not going to get hurt on this CarTrain, but I want the students to understand what they're doing.
The whole procedure.
The whole procedure. So
I remember Skills USA.
We'll try and do this a little bit quicker so that it's not so boring for everyone, but we want to really emphasize just how important this is for the process.
Absolutely.
This is what it's all about. So we want those students to understand what they're doing before they work on the real vehicle. So glasses, obviously, very important for eye protection.
Do you see still enough?
No, but we'll work it out.
Yeah, I help you.
There's the gloves that we see here as well. So there's two different types of gloves. One is, this is what we often see in Europe, places like that. There's just normal long sleeves gloves. And then we have the US type as well, which are not as long. You can see there is a bit of a difference between them.
This guy is okay.
And thank you. And then we have the US ones also have these leather gloves that go on top as well to protect the rubber gloves. So these are actually a lot thicker than these ones here.
Yeah.
So these can be damaged quite easily, and which is why you have the insulation, the leather gloves on top. So I'm going to put these ones on today.
Oh.
But, well, this is a late webinar, so it was intended for the US and places like that.
They are okay.
Yeah. So things on here that you have to look for: class 0, 1000 volts. That's very important. Mm-hmm. Should also be a test date on them as well.
Absolutely.
So very important that they're within the date. And what I like to do, there's a little trick. So what you've just done there is you've done it this way, flicked it around. What you find, there's not much air in there. If you turn this to the side and do it, it captures a lot more air within the system.
Smarty pants.
Just to annoy you. So go through and you can have a listen. It's actually quite impressive. We make bad ones of these. We put pinpricks in there and things like that. You've actually got to put a fair bit of pressure in there to feel that. So you've got to go through, try and hear it. Obviously, there's proper ways of doing that's the so-called field test is doing it like that. So I'm going to put this one on. Have a look. So the first thing you do in a situation like this is you do a visual inspection on the vehicle. So you go around, okay, I've got an insulation fault. Thank you very much.
I always want to help you with that.
And the vehicle's turned off, and you'd have a look around and say, okay, so far everything looks fine. We might have to go into the next step, do some testing or having a look at the parts there. So there's different ways of doing a shutdown on these systems. So one, now that I've put the gloves on, I'm not going to do the way on the laptop.
Tester-based shutdown.
There's a tester-based shutdown, but there's also here we can remove the manual service disconnect. I could also remove the low voltage connector here, but just because I got the gloves on now, I'm going to go through and do the manual service disconnect.
So that's the old classic way, right? Basically.
Exactly. So there's also the 12-volt battery, because that's controlling my the controls for the battery. So if I'm just removing that, that's the first basis of shutting it down. So we've done that. We can then also come along here and try and remove the manual service disconnect. So I've pulled that out. Maybe you can help me in this case
box.
here. Safety box there. I've also put the key, the smart key in there. So no one can come along and start the car. By removing the key, if someone comes along and tries to start it, it'll say the key's removed.
But we have basically multiple level of safety when we disconnect the 12-volt battery.
We can start it anyway.
Normally, yeah.
Exactly. So it's all about building safety in. So because there's been cases where You know, the mechanics are working on the car and the service advisor comes up and says, hey, I just need the kilometers. How many kilometers has the car driven? And they press the ignition on, and someone's in the back of the car trying to measure something, and all of a sudden it tries to start up again. And yeah, so perfect. What Christian's just done now is put a lockout tag onto that safety box.
No one else could open it and reinstall it.
Exactly. So you've got that, should have my name on it now, and that's the components, the key. If my name's locked out, and then I put the key in my pocket right here like that, so that no one else can do it. Okay. Now I need to do what's called a live dead live test, because I want to make sure that the system is actually dead. Because just imagine this vehicle has a problem. It's in the workshop because it has a problem. So I've just got this out of our project case. This is delivered with it as well. And I need to go along then and inspect to make sure that the high voltage is actually gone. Because you can imagine if those contactors we mentioned before about weld testing, if they were welded shut, there could potentially still be 400 volts, even with the battery disconnected. So in order to be safe, we're going to check. Trust but verify, they like to say.
That comes from Australia. No. No, I'm not allowed to touch. Sorry, I don't help you. Okay. So
very good. So I've just removed that. Now I've got access to the points here. This is our inspection point. So you can't quite see that on the video, but there's an extra bolt up there which is connected to our positive. We can see that circuit diagram. We've got positive down the sides here, and we've got the negative side here as well. So now I'm going to come along with my multimeter. Yep, perfect. You can tell me what it is. I'm going to come along and I'm going to make sure that our multimeter is working correctly. So I need to come along here and put it on our 12 volt battery.
12 volt.
Okay, 12 volt is working. Now, when I come to...
That was the first live now?
That's the live of live dead live.
Okay.
Now, come along to checking. I'm going to just use one hand. This is the one hand rule. And what I like to do, I don't know if you can see that, I put one hand behind my back just so I don't, otherwise I'm going to grab with both.
Which could make a closed circuit.
Exactly. So put one on there.
Okay.
If possible.
You can. That's why it's so important to train that, right?
Exactly. You can use a crocodile clamp if you got one.
We have 264 millivolts.
Millivolt. Okay. So that looks like 0, but I'm still not sure. So that was dead. Live, dead. What happens if I just blew up the meter? These have fuses in them, these meters. And sometimes, you know, this one's pretty sophisticated, but some...
When you have some simple ones, basically.
You have some simple ones.
That would show the same then when the fuse is blown.
They can do. So then what I do, and I can now use 2 hands on this battery and check to make sure. And I've got 12 volts again. So I know now that my system, I'm not talking about the battery is still high voltage.
Always.
Always. Yeah. Even with the service disconnect removed, it's always still high voltage.
But we made sure that the relays are open, basically.
Exactly. Yeah. So we've verified. So now I come along and I'm going to continue my search here. And now, obviously, I found this a little bit quicker, but right here, I can feel on the back side of this cable is, you can feel that that insulation has been...
Yeah, there's real damage, obviously.
I come along here, and now where can we see that?
Okay, that's hard to see.
So right here, as an example, we've got some damage to the high voltage cable.
It's an actual damage. There's a real
actual damage.
Yeah.
So, and this is from our project case. There's a part number that you see on here. And so the part number is also what you find in the scenario. And the student would then need to say to the instructor, the teacher, and say, hey, okay, look, I found a problem here. I need a new one.
I order a new one.
Here's a new one. So,
hey, okay, this is the repair process.
That's the repair process. So now all of a sudden, okay, I've got a new one right here. I can come along and fit that to my CarTrain. I still don't need gloves right now because the system is completely, yeah. And so that's now good. I can go through here.
Okay, so now I have to replace everything basically.
Exactly, put it all back into operation.
But the basically the high voltage service disconnect, you have still to use the gloves, right? As you are in the high voltage battery.
Absolutely. So in the high voltage area, we always have to use the gloves. So I'll put this back into.
Don't want to get in your pocket for your keys.
So this is actually, in some cases, this is would be, you would go to jail if you come along and remove that lock. Some people cut them or something like that. If you did that, you could definitely be in a lot of trouble. So what I'm going to do now, I'm going to put the European gloves on just to mix it up, to show you the difference. Thank you. Now, you can also see on here, maybe you can't, but there's a 3-stage lock to this. So there's detents, and then there's an extra detent. So it's not something you can just accidentally pull off. You've actually got to deliberately try and remove it here.
This guy look really serious.
Absolutely. And there's also an interlock on here, which we haven't mentioned at all.
I mean,
but
this is why we pull it out.
Exactly. So we're breaking apart the system. Now, again, one hand rule, push that on. That's in place again there now.
And I'm allowed to put the smart key in?
Put the key back there as well.
You're welcome.
And put the 12 volts back on. And let's see, we might need to clear the codes. Take it for a test drive.
Yeah.
Go for a look around. So far, before it turned on already. So in this case, we've now repaired the vehicle.
But that's interesting. You don't need to deactivate the fault manually. The car is recognizing it.
The fault is the cable. This is an actual faulty cable.
I just know other training systems where it's like, oh, okay.
You know, there's a switch or something there now.
Exactly.
So that's, you've actually gone and done the repair as you would in a real vehicle.
And that's really cool for the, how you say, for consciousness of the student, that he really sees it's logical for him. He had repaired it.
Absolutely.
And it's repaired.
Absolutely. Now, let me just ask, have we still got people on board, or have they all gone home because they're bored? 70 people. So look, if you're still here, we're already 10 minutes over, but I think we can, what I'd like to do is just show one more installation fault in the very least, because, okay, we've done a hardware fault here, but what happens if we have a fault within our motor generator? So we actually have on this system, we have 2 installation faults, one within the air conditioning, which is also very common in the industry.
Okay.
And then we have one in the motor generator as well. So these are very common faults that you see here. And I wanted to show you the difference between the 2 types of installation faults. So one here was a visual inspection where we found an actual damaged cable and we changed it. This time we want to use the installation testing equipment to do that. So what I'm going to do here is go into our admin mode and to the fault switches.
Yeah.
So right here, I have to go onto this one. So, so now I've just switched on a different installation fault. And so now we've got the yellow fault come up.
Which we can read out then again?
In the tester, in the scan tool, it'll tell us that there's an installation fault there as well. But in order to go a little bit quicker, I'll just give you the breakdown on what we'll do there.
Yeah.
So we need to, of course, shut down the system again. So Leon, maybe you can just switch it back to my, yep, perfect. Oh, the team that we've got here in the background is amazing.
For sure.
So now we can see here we've got an installation fault detected. Again, I can check that, 1 of 1. And I can go down here to special functions and we can go to isolation.
Okay.
So what does that look like? So Chris, maybe you can do that for me this time. So
And now I'm able to work for you, okay?
yeah, exactly. So at this time, so in countries, there's a sign.
The warning sign, yeah.
In some countries you need that, some you don't. But this is what manufacturers say. Just
We
if you
say
need
it's
go
there.
for it. So this time only switch on the ignition. So
Right now
the ready mode is on. We don't need ready mode.
So I go
Oh,
off.
sorry.
Sorry.
Yep. So switch the ignition on.
So I just go on ignition.
Yep. Yep. That's it. So, and now I press here, go a little bit further. Okay.
Now the tester is interacting with the car.
Exactly. So what's actually happened is the system, you can see here now on the screen.
Oh, sorry. High voltage system active. Yeah, of course. Yeah, right now it's still active.
Even though we're not in ready mode, the relays are on, because what it needs to do, it needs to test, it needs to do that live test internally.
That it's like reliable.
Exactly. So it needs to check its own measuring devices. So that's what it's doing here, because we're not going to measure anything on the high voltage system ourselves.
Now I heard a noise.
So now to switch off the ignition.
Done.
Okay. I'll go back here. If I try to do that, it'll say now disconnect the plug of the green. So you can see, I missed that. I didn't tell you that. Might have to use one of these. That's why I left it out when you pressed it in before, by the way.
I like the challenge.
There you go. So this is now the green little plug, which Chris has just pulled out.
Well, we have like a smart tool here.
And you need to then put the padlock inside of this as well.
Yes, boss.
Yes, boss.
Why?
Because that's also our tag out for this here. So you're now working on the vehicle.
Yeah.
You've got your padlock on there to say, hey, look, I'm working on it.
Okay.
The system, this is actually opening the interlock. It's a little bit tricky, this one, so to sort of carry on.
I'm learning. Thank you.
And so now the system, the interlock is open. So if I try to start it, it won't start, but I don't want to do that right now. And I come back to now my tester here, the scan tool, and I can say here, okay, now switch on the ignition.
Just
so
the ignition.
Just ignition, not ready mode.
I have a gut feeling. High voltage system de-energized.
Now switch the ignition off. There you go. So now the system has done its own live test, and we can then safely shut down the vehicle. This is for many vehicles don't actually have this manual service disconnect anymore. The manufacturers don't want technicians playing on the high voltage system.
Yeah.
So we're going to go through. I have to do a insulation fault. Now, insulation fault we can do with the same device here again as well. You should use the gloves when using insulation tester.
Oh, because the testing voltage is pretty high as well.
Exactly. Right? 500 or 1,000 volts, things like that. So now, as we said before, we normally don't have 4mm measuring plugs on systems like this, but just to show you what we can do, we're going to go ahead and do that anyway. So if I go down here to insulation.
Now you make a connection over the whole high voltage system.
Exactly. So what I've got down here is to ground. So you can see the ground connection. So that's the chassis. And that's maybe we should take a quick step back and say, well, that the insulation fault is the high voltage system is somehow on the ground of the vehicle. And you could probably imagine that's not good, because the ground of the vehicle is the body of the vehicle. In automotive, the body is the ground. So there could be pretty big potential to hurt someone. So we can do a quick measurement here. You can hear the system, it's buzzing away.
What?
And we can see here.
Oh, it dropped down.
Yeah, it's dropping down. So it's measuring here at 500 volts, and we've got under 1 mega ohm.
And you have a warning sign up there.
Exactly. So it's actually on. If you put those together, or if I touch you with it, you get it zapped. There's 500 volts. Don't do that. But right now we can see here it's at under 1 mega ohm.
The voltage was 522.
Yep. So at that voltage, the system broke down, didn't get any higher, and we only have a resistance of under 1 mega ohm.
Yeah,
That's not enough for the automotive industry.
Okay, now we know there's somewhere a problem in the high voltage system.
Exactly. But how do I go about finding where it is. So what we then need to do is then isolate the various parts of the vehicle. Now I'm going to, just for quickness, I'm going to remove these gloves because they're, if we go through and do that test again here, we should see,
Well, now. Okay, it's doing it. I see.
sometimes it needs to build up the,
Yeah. So
there
1.6 mega ohm.
yeah, 1.6 mega ohm.
But that was clear because you removed the cable, or am
Yeah.
I wrong now?
Yep. So that's because we're in the battery, so the fault wasn't there at the system there. And check that. Going again, start.
Okay, it's measuring.
Going up to giga ohms.
Wow.
So 0.6 giga ohms this time. So that's 600 mega ohms. And then, so what we need to do though, if we're doing this on a real vehicle, we need to come back to those measurement adapters.
Yeah.
We don't actually have those connections on there, so and check that.
But now it's like in the real car.
Now it's like in the real car.
Okay, it's measuring. Giga.
You see that again? So we know that the fault is not on this side.
Okay.
And we can bring that down here. So it's so high that it's basically an open circuit.
Yeah.
Which is what we want. Bring it over this time to the electric motor. We can see there, what's the breakdown voltage this time?
21.
So it only took 21 volts out of the 500.
Have kilo ohm now.
Yeah, kilo ohm. So we've now isolated the fault down into the motor generator here.
Ah, okay, I see.
So, and that's the case then where you would say to the customer, okay, we need to replace the drive motor in the vehicle.
Okay.
So
yeah, clear. You really focus it on one problem, basically.
Exactly. We also have
on one
faults
part.
like that within the air conditioning compressor.
Nice.
That would then be a different, slightly different. We have to remove the cable and things like that. So
okay,
way too much to go through.
Yeah, in order not to break it, like I said, you have a same bunch for faults for the high voltage relays, right? We
lots of different faults.
Everything.
And maybe what we should just show is what we didn't show before is the possibility once the fault is on there.
Measuring possibility.
And why we had two of everything. So when we put a fault into the system here, we've seen the fault menu, which I had before, and up here, that was the motor installation fault, but we also have lots of faults for the relays, which are here as well. Where am I here? So, and that we have two of each of those. So when you put the fault within the system here, it stays within the training system.
That's a smart fault then, basically.
It is, absolutely. And then you have a spare one of each of these as well. So, but in order to actually find it, the fault stays within here. And you can see here we have, on one side, we have our high voltage connections from the battery to the DC link up here. But then we also have here the yellow and the black connections. And these are our coil windings.
Where you can directly measure the relays then.
Exactly.
Relays. So we have a movable part which we put in. We activate the fault. The fault is like activated in the relay. Then we take out, we find out that it's faulty. We take out the faulty relay. The fault is still there, so we can measure it that there is a fault. Then, of course, we call our friend and order a new one, a brand new one. Get this, build that in. Put everything together.
The fault is gone.
Fault is gone.
Yep.
So like again, a real repair process.
Yep, absolutely.
From start to the end. Amazing. I don't know. Well, you know much more to say, but as we say, we don't want to explode the time limit too much here. I hope you're still interested.
Yeah, so we're sorry for going over time, but we're pretty excited about the system, and I think it takes a long time to explain it. So
he could go on for days.
Yeah.
But now it's about your voice. Are there any questions from the QA, Caro?
How we will get a certificate for this participation from today?
For the webinar?
Yeah.
Oh,
we haven't planned any
certifications, exactly. We can talk to our marketing department if they have an idea.
Yeah.
So we have all the names. Yeah. We see what's possible there.
Okay.
Then how can we train the trainers? Is there a concept for training the trainers?
Yeah, we always send someone out, or there's, well, when I say we always send someone out, we've already sold quite a few of these, and I don't think we can train every single person, but Chris and I have done many videos online, so commissioning videos and things like that. I dare say we'll be able to do this here as well, but the idea is that the system will be very intuitive. There will be videos to support you. There'll be video calls, things like that.
Yeah, but in case we send out one expert from our side in order, because very often there's also other things ordered. So then we will send out an expert who do a trainer for a week, for a couple of days. But like Daniel said or mentioned, this system is pretty easy. It takes seconds to get it into operation. You just have a normal power plug, so no three-phase or whatsoever, even if it's a 400-volt system, and you don't have any real batteries on that system. That's a huge benefit, as you don't need to recharge. There's no maintenance, there's no service, there's no danger goods delivery. So the system is not only designed for the students to be used easy, it's also for the instructors the way used. Even after 6 weeks after, or how many weeks after the summer break or whatsoever, you just start the system and you can directly go on.
Yep, absolutely.
So how will you port the program for universities? In my understanding, we are supporting diagnosis so we can take forward to implement UGI and PG projects.
Okay, for the CarTrain focus the vocational training, I would say, in the first place. But it also, we had the cases already with other CarTrains as well, that they are used in the university for the first step. But because even when you do a research, at first you need to understand how you work on a high voltage system, which faults can appear on a high voltage system, and how you protect yourself, right?
Absolutely. So there's a basic understanding. So technician training, vocational education is more about repairing, fixing, and things like that, whereas the engineering side, which is normally what you find at universities, is about designing the vehicles. But as you mentioned, Chris, the people that you still need the qualifications. True. And there's actually a higher qualification for prototyping.
DGUV, yeah,
yeah,
exactly.
So DGUV on the third level, like the third level, or IMI, that's where you're working on live high voltage system. So what we've done is the basic level. There's actually another higher level if you're working on the high voltage battery.
Yeah, where we also have a CarTrain for it.
We also have a CarTrain.
The brother from this one.
And so yeah, we have had a lot of people say, especially things like the energy flows, all of that is still good to know how these systems work together.
It lays the basic which you need in any direction.
Exactly.
Doesn't matter how you go.
We're not doing things like MATLAB or anything like that, programming the
That would be the friend
drives.
from other product area.
Exactly. Electric drives, for example, they're doing things
so
like
if you have there certain questions, maybe how you can even combine it with more higher university stuff, just write to us, write to our sales guys, and they will find a common solution for you, I guess. Yeah.
Yep.
How can we get a quote?
How can we get a quote? Okay.
So we're going to send a mailing out to you after this. If you've participated in this webinar, we've got your email address,
yes,
obviously now. So we're going to send out after the second webinar. So
On Thursday,
later
yeah.
this week or early next week, we're going to send out a mailing. It'll have the contact details on getting in touch with us. And so the way we work, we have local representatives in each country, and they have an area sales manager here at Lucas-Nuelle. So they'll be able to get in contact with some local.
If you can't wait for it, just go to the YouTube International Lucas-Nuelle account, and there you have the automotive EV playlist where we have a bunch of different complexity videos for this CarTrain. And in the end, you see all the contact details in the email where you can write to, where you just address CarTrain, diagnose and repair of high voltage system, quote, and our sales team will take care of this.
Yeah.
We send out a list with all projects or faults that can be.
Yep.
You will get this. This is what we have here. So you will get this as a digital printout, basically, and this will be included in the package which you will get.
What I'll just mention here is that there's going to be levels to this. So there's 28 that will change. So because we're building more projects as we go along. What we've done, however, with the system is if you don't need all of the projects, basically we start off with, I think it's 15 projects that start with the system, and you can purchase some extra ones if you want to go deeper into some of those topics or some of the topics that are a little bit more different to.
And we have
might
like
not be interesting
2
for you.
projects on general terms. We have 6 projects on power electronics, 1 project on potential equalization, very interesting topic. Then we have another 5 on the electric motor, 2 on the onboard power supply, 3 on the high voltage battery, 3 on the onboard charger, and another 6 on the high voltage relays.
And with the relays, we can actually do a lot more than that because we have the different types. That's just on one type of relay. Then we can have
6 multiply with 3.
With the projects, doesn't matter. You can see here, we're going to be using this in a lot of skills events around the world as well. So, and that's going to be where we don't use LEA, for example. The students are going to have to go through and use the diagnostics and the scan tool and to try and find that themselves. So I think this is going to be very interesting for like
Skills USA
or skills, but also like an exam.
When you do testing assessment,
exactly.
For sure, yeah.
So here's a problem. I'm not going to give you any more information. You need to find it and then repair it or give the information.
And they can do faults, and you don't need to be afraid as an instructor, like on a real car, that the car kills the student or the student kills the car. Yeah. So
Exactly.
that's a big benefit. You can just sip your coffee and be relaxed.
Yeah. Questions are still coming in. That's awesome.
If a fuel cell vehicle is found fault, how can it be rectified?
Well, there's lots of different faults that we have there, I guess. Depends on which one you're talking about. But I guess if you're talking about inside the fuel cell itself.
Okay, that's a certain special topic, I would say.
Yeah. So the fuel cell is usually what's called a fuel cell stack. So a fuel cell, similar to a battery cell, is able to produce a certain amount of voltage according to, what's that called? The chemical, the series chemicals, depending on the potential. So basically in a fuel cell, just quickly, is stripping the electrons off of the hydrogen in order to use that electricity for electric drive. Long story, but however, the more you have a stack of those cells together in series.
But automotive mechatronic won't repair a fuel cell stack when
No.
is broken.
So
right?
I just wanted to give the background knowledge that the fuel cell is a stack, so it's a big thing, and exactly as you say, you're not going to be repairing
the same, right? How to jumpstart a fuel cell vehicle? Would this be the same way?
Yeah.
Like, okay.
Exactly. You still have the 12-volt battery that is controlling that. And the reason that is such a big problem, is that the battery is much smaller on this because we don't have to start the engine up.
Yeah, for sure. Yeah.
So you've got the high voltage battery is sort of, and the DC converter is producing most of the current.
The fuel cell.
You only have to switch the relays on. So the batteries are much smaller, but means they die much quicker as well.
Nice.
What's the availability of spares here in Uganda, Africa?
The spare. It doesn't matter where you are. The spare parts coming from us. So when you need anything, you just order this over your sales manager, and he will send it to you.
Yep.
So it doesn't matter where you are, we take care that you get spare parts. So even when these are real spare parts, you can order them over us.
You won't find it at the local
Of course, yeah.
place, but we definitely have all of that available.
Yes.
Can you virtual control the system for an online training?
That is not necessarily what we're trying to focus on. So I think what that question is referring to is we've seen that distance learning, but that's where
I think this is where RXLea comes in. RXLea can be used for distance learning.
Yeah, absolutely.
But what we do on the hardware has to be done on the hardware.
It has to be done. You need to be here with it. So you can certainly have a look at the RXLea when you're at home, things like that.
From everywhere.
Because I know that from some of our colleagues who use MATLAB and things like that, you're able to program, you create your own program and then upload that and see how the system works. But there is so much hands-on on the system. The main focus was hands-on. So you have to be here for the system to
have any circumstances, whatever will come up in the future. But of course, you can as an instructor make a distance learning lesson where you show just something on the CarTrain. Like we said, you can transfer the display on your computer basically, and then make it available to all the students which are around, and you can go together with them through RXLea. They can open it from anywhere. So, but yeah, it doesn't make sense to flick a switch over the internet basically. As hands-on training, EV safety, you only gain if you are working on the system.
Yep, exactly.
Okay.
That's it for today.
That's it. Perfect. Thank you.
Excellent.
Now I have quite a few questions. Well,
yeah.
Good rundown. You see, there would be much more to say, but we don't want to use more of your time for today. So thank you that you still are here. We hope you like it. We're looking forward to see you again. Check out the videos on the YouTube channel. Hopefully that was interesting, gave you some insight onto how EVs work and some of the diagnosis that can be done on them as well. We never know, when you get a quote and you get your CarTrain, maybe we see each other then again in person. That would be awesome as well. Okay, then from our side, we wish you an amazing day. We stopped the working now for today. That was our last action today, but it was the best end basically. Absolutely. Our working day could end. So we're looking forward to see you again. If you have any further questions, just write to us, write over YouTube, wherever you want. And yeah, we wish you a great time, and we hope that you soon get your CarTrain then. Thanks for joining, everyone. Have a good one. Great having you. Bye. All the best.